Hello, flatties
I'm
and
ready, man.
globe defenders and all others. It's Critical Thing from Down Under. And today I'm interviewing a wonderful gentleman who has an interesting past, a thing that we always wanted to do is program video games. And he's the one of the authors of Tony Hawk's Pro Skating. And, or I should say, Tony Hawk's Pro Skater, or otherwise known as Tony Hawk Skateboarding in Australia. And of course, you all know who he is. He's Mick West from metabunk.org. Welcome, Mick.
Thank you for having me. Glad to be here.
Okay, now I must admit I haven't had a chance to read your wonderful book. Now you've released this book,
Oh,
which
yeah.
is Escaping the Rabbit Hole. So yeah, tell us a little bit. I know you talked about a lot about this book with Soundly, but tell us a little bit more about your book, please.
Yeah, the book's basically a kind of a distillation of everything I did on Metabunk. Metabunk's like this forum where we talk about all kinds of different theories, like including like the flat Earth theory. And there's a chapter on flat Earth in the book. But the book's really about how to talk to your friends and relatives and loved ones who might be stuck down some kind of conspiracy theory rabbit hole. Like if you've got a relative who's a flat earther or a relative who believes in, kind of extreme 9/11 type conspiracy theories, how do you talk to them? And so that's what the book's about. It's just basically this is how to debunk conspiracy theories using facts, logic, and respect. And that's what it's about. There's a big chunk on flat Earth in there as well.
Yes, I'm interested in flat Earth, of course, myself. I've not actually got into any of the other conspiracy theories really, but you have a fairly intimate knowledge of them. And how do you go about debunking things like 9/11, for instance?
Well, you can't just say like, how do you debunk 9/11, like the whole thing. You got to look at the actual individual claims of evidence that people make. Like if they make, if they say something like, the building fell too fast, or there were these puffs of air, or they found iron microspheres in the dust, or they found nanothermite in the dust. You look at the actual exact claim of evidence that they are making, and you see if it stands up to scrutiny. Like, for example, the claim that they found iron microspheres in the dust is a true claim. Iron microspheres were found in the dust, tiny little iron spheres, but they claim that it could only have come from nanothermite, which is this kind of exotic explosive. And I looked into that in great depth and showed like 10 other different ways that these iron microspheres could have occurred. So you can't say I have debunked 9/11. You can't say I have debunked flat Earth, or you can't say I've debunked chemtrails. But you can say that I've looked at these individual claims of evidence, and these particular claims of evidence did not stand up, and here is why. And you can go check it yourself.
Okay, that's very interesting. And how fact resistant have you found people to be?
Well, there's a vast variety of degrees of fact resistance. It depends what you're talking about, because sometimes if you show somebody a simple fact, like for example, you say that iron microspheres can be made by striking a lighter. Like for example, if you get a Bic lighter, I think go on somewhere, just a standard lighter. If you strike it, it makes these iron microspheres. They might not believe you at first, but then you demonstrate it to them, and they can't deny that that's actually happened. So they're not going to be fact resistant and say like you're faking these microspheres shooting out of this lighter. So they've got to kind of accept that little bit of information. It's not going to change their mind on whether 9/11 was a controlled demolition, but it's kind of a slow accumulation of facts, or rather a slow chipping away of their false facts, and an addition of the true facts. So you show them things that are actually real, and that demonstrate to them that certain things are not real, and eventually the balance begins to shift. It can take a long time, and it varies a lot by individual.
This is a very interesting topic to me, and you've spent a lot of time dealing with that sort of thing. So, I mean, as I said before, there are many of us who thought that your previous job was a dream job, to be a computer game developer. Something that I always wanted to do. But how did you go from being a game developer to get into investigating conspiracy theories?
Well, essentially, I retired from game developing, and so I had a lot of spare time. And really looking into weird things and looking into conspiracy theories has always been something I've been interested in. When I was young, I was very interested in things like UFOs and even ghosts and the paranormal. And so I was interested in looking into them. Originally, they were just fascinating in themselves, but later got very interested in figuring out what was going on, especially as I got older and got better at doing things like math and geometry and visual image processing and stuff like that that you do in video game development. You do a lot of 3D graphics, so you understand how things work, which is very helpful when you're doing things like analyzing UFO videos. You can figure out where something would be in 3D, and of course that also comes in very handy when you're dealing with a flat Earth, because there's a lot of 3D geometry involved and understanding of how cameras work. So it was kind of a combination of my interests before I got into video game programming, and then during that time, I did lots of reading about this type of thing, reading about science, and then after I retired, I had a lot of spare time, so I just did things that I was interested in. I took up flying. I was doing a bunch of other stuff. And one of the things is looking at conspiracy theories, and that's how I got into it.
Okay, so with the UFO things, I must admit I don't know a lot about it, but if you're just on the fringe, you think, well, there could be something in this. What's your take on the UFOs?
Yeah, sure, there could be something in it, but again, like you got to look at the actual evidence that people put up there. If there were aliens visiting, you think there'd be a few more photographs of them. There's really not that many more photographs now than there were, back in the 70s or 80s. But now we have cell phone cameras, and we have everyone has a 4K video recorder in their pocket, and lots of people have these very very long zoom lens cameras like the Nikon P900 and the P1000 that should be able to show you the details of these things. Because before, people were taking photos of UFOs with their crappy little Instamatics, or they're just a regular 35 millimeter camera with a maybe 100 millimeter lens on, and now you've got cameras with you can record 4K video at 2,000 or 3,000 millimeters with the Nikon P1000. So if there were things out there, we should be able to be getting much, much better video of them now. And we're just not. We're just getting the same things. As soon as you zoom in on something, it's revealed what it is. And that's the problem with these UFOs, is that they're only unidentified because they're just a bit too far away. If you got closer to them, or if you zoomed in a bit more, you can see that it's a bird, or it's a plane, or it's a balloon, or it's a cloud, or whatever the actual explanation is. So no actual UFOs have really been discovered up to this point. People will argue otherwise, but really they're looking at blobs in the sky that you can't tell what they are.
That's a very good point you make about everybody has a camera these days, and it's something that I didn't really think about, but that just certainly makes a lot of sense to me. I mean, you would see that. You'd think you would see them all the time if they were there. That's right.
Yeah, you're probably getting more than 100,000 times as many cameras out there in the wild than there were before. Because people, cameras. Sure, people had cameras, but they would take them. They wouldn't carry them every day. That's the thing. Like now, everybody carries their camera everywhere they go. They even have a camera on their bedside table. If an alien comes to abduct them at night, they could grab the camera and take a picture of it. Whereas before, that's something that they could, just people would take their cameras on holiday, or they would, take them to the museum or whatever. And generally, for most people, there'd be a little 135 Instamatics or whatever. So the actual amount of high quality cameras, there's hundreds of thousands of times more than there were before. It's just cameras. Everybody has some kind of cell phone handy. Even the crappy ones nowadays take very very good photos.
You've put together this book. So how did the idea for the book come about?
Well, I've always wanted to write a book about some kind of debunking topic, and the way this one came about was my only book. Is that I was on the Joe Rogan podcast because I'd been on his show. Joe Rogan Questions Everything. Joe Rogan's he's a kind of a multi-talented guy. He's a comedian, and he does UFC, and he has a very popular podcast. And I got on his podcast because I was on his show talking about chemtrails before. And basically, what happened was someone from the publisher saw me on the podcast and thought it would be a good topic for a book. And as I'd always wanted to do a book on these topics, it was just a perfect fit, being in the right place at the right time. So they called me up and, said, do you want to write a book? And a year later, here it is.
So I have read just snippets of your book. I haven't had time to read the whole thing, but it is very, very interesting, and I do recommend people get that book and read it. Just a few
Thank you.
things that I've read there. It does remind me a lot about some books I've read about cults, really. You think that there are similarities in that?
Definitely. And I think the primary difference between a cult and a conspiracy theory is that a conspiracy theory doesn't really need a charismatic leader. Cults kind of generally center around one individual who is a very charismatic leader. Now, you have leaders to a degree in the conspiracy theories, but they're not the focus of the conspiracy theory. It's the claims themselves. So it's different in that regard. But in other regards, it's very similar. You have this set of beliefs that everybody buys into, and they're very passionate about it. And they think that what they are doing is very, very important. The people who believe in conspiracy theories, like chemtrails or 9/11 or even the flat Earth, think that they've discovered some fundamental truth about the way the world works that other people don't know, and they think it's kind of their duty to show this to other people. And so there's this very great similarity. If you look at cults like with the Jonestown cult, which was the Jonestown massacre, where all those people took cyanide in Guyana. They thought that they were basically fighting against a capitalist system and standing up for the little person, standing up against racism and all kinds of really good things. And so they thought that what they were doing was very important. And they ended up all taking poison and killing themselves. With conspiracy theories, the conspiracy theorists, they're very well-meaning. They're actually, most of them are good people who are trying to do good, and they think that they've discovered, like, for example, that the government destroyed the Twin Towers on 9/11, or they think they've discovered that the world is flat, or they think they've discovered that chemtrails are, changing the climate, and they're trying to tell people about it to improve things. So that they mean well, but they're basing it on a false premise, which is similar to the cults in that way.
So there is some talk also that some of these conspiracy theories are manufactured to divert our attention away or to disrupt our government or something. I mean, how do we know what's right and what's not right?
Well, I think regardless of whether they were manufactured to distract from what the government is doing, that's what actually happens. If someone believes in chemtrails, they're not going to look at the much more mundane forms of pollution. And so it's in the interests of people who want to, get away with things like other forms of pollution to distract. Now, whether they're actually doing that or not, is kind of like a separate subject. But the fact remains that, if people, believe in these extreme conspiracy theories, they're not paying attention to the other stuff. So you could see if, say a foreign power, for example, wanted to sow confusion in America or in some other country, they could start trying to popularize ridiculous conspiracy theories just to increase the amount of noise in the public discourse and to distract people. Some of the people who are into conspiracy theories are actually quite good at promoting those theories. And if they were actually promoting some kind of real issue, like say they stopped rabbiting on about chemtrails and they started talking about the pipeline issue or oil pipelines or offshore drilling or fracking or something, like some actual issue of real concerned something's actually happening, regardless of whether it's right or wrong. But if they started talking about real issues, they would have more of an impact there. So it's like they get all the loudmouths to go talk about chemtrails instead of focusing on the real issues. So it's a distraction, and that's one of the reasons that I like debunking it, because I think if I can turn someone away from talking about nonsense all the time and have them instead focus their efforts on talking about real issues, then that's going to be a net win for society and for everybody.
Yes. So one of the interesting things for me is that, all right, from our point of view, a lot of these things are ridiculous, but from other people's point of view, they seem to make sense. So in terms of our own things that we think about, should we, like, in terms of question everything ourselves? How do we know that we aren't one of those?
Well, I think it's always good to double check things. You could ask somebody, is the Earth flat? And they will say, well, of course it's not flat. That's ridiculous. It's stupid. And then you ask them, how do you know that it's not flat? And they often, the answer they give is essentially boils down to that's what we were taught in school. And then they will say some things like, perhaps they'll say ships disappear over the horizon. And most people haven't really thought about it, and that's actually quite a reasonable thing, because there's no real need to think about whether the Earth is flat or whether it's round, because it's been established over thousands of years of science. And if you wanted to, you could actually go and check to see is the Earth flat or not. But I think it's always good to check your assumptions. And I actually, I've done a bunch of experiments. I didn't really doubt that the Earth was round, but I did experiments to verify it. And there's some fairly obvious things you can do, like looking at distant islands being obscured by the curve of the horizon in the distance. You can look at, if you look south from anywhere in the northern hemisphere, you can see the constellations revolve around the southern celestial pole. And you in Australia, you can look north and you can see that you can't see the North Star from where you are, but you can still see the constellations rotating around the North Celestial Pole. There are very simple observations that you can make, and they used to actually teach children in school some of these things back before the 1960s, and it kind of went away because at that point we had the space program and we started getting photographs of the Earth from space and measurements from satellites and things like that. And so there was really no need to teach children things like why we know the Earth is flat, because it's bloody obvious that it's flat. It's why we know the Earth is round. It's obvious that it's round because you can see it from the cameras in the space station, you can see it from the satellites, and you can see it from the photos on the moon. And it's only when people start to doubt things like, did we actually go into space, that becomes an issue. And since that's kind of in a way a ridiculous conspiracy theory, the schools don't feel any need to teach things like why chemtrails are actually contrails, and why the World Trade Center collapsed under gravity and things like that. And they don't feel any need to teach people how you can determine that the Earth is round based on the evidence of your own eyes, because we've got so much other evidence from space, from satellites, an overwhelming amount of evidence that it's just not necessary anymore.
Yes, but given the a large amount, well, what seems to be a large amount of people that believe in things like chemtrails and flat Earth in particular, do you think this sort of stuff needs to be put back into the schools?
Yeah, I think people need to be taught about how to, I guess, check reality, check the scientific model of reality. And there's a concept called ground truth, where you have remote observations of things and then you have the local observations. And you say, for example, you have a picture of the Earth from a satellite. That's your remote observation. And that will show some clouds on the ground. And then you have the ground truth, which is what things look like from the ground. You can look up and you can see the same clouds, and you can kind of match them up to what you can see from the satellite. So you can teach kids how to actually verify these things. You can teach them how to verify, you can teach them how to do things like calculate the radius of the Earth. which is always a fun thing to do. Try to figure out some number which matches science. You're probably going to get somewhere between 3,000 and 5,000 miles radius, because the measurement you do is not very accurate. But people can actually calculate the radius of the Earth in a variety of different ways. You can do it with using the Eratosthenes method, the stick in the ground with the shadows and everything. You can do it by seeing how much mountains are obscured.
Yeah, that's right. I'm going to do one such thing in a video I've got planned coming up, and measure the radius of the Earth. Yeah.
And these are fun science things, and they're good things for kids to do. Even if you're talking about something which is kind of indisputable, like one thing we do in school, people will measure what the gravitational constant is, like the local acceleration due to gravity, g, which is 9.81 meters per second, depending on where you are. And kids will actually measure that, because that's a fun little experiment you can do. You can actually measure it fairly accurately. And you could take that another step further, and you could say, like, we'll measure it here down at sea level, and then we'll drive up a mountain and we'll see if it changes. And it does actually change. You can actually detect a small change in G based on where you are relative to sea level. And you can do it, like measure it in different places at sea level. It varies there as well, because the composition of the Earth varies. So there's these fun science experiments that we can do that actually will demonstrate things like the actual mainstream scientific model of the globe, and I would encourage people to do them. Good field trip, going out to the lake and doing observations across a lake and things like that.
Yes, I did want to ask you about the guy that calls himself Dr. John D. He claims to be a scientist of some kind, but he doesn't seem to be very scientific about the way he talks about you, and now Ruhif, a friend of mine here in Australia. He doesn't seem to take criticism all that well. And
no.
What do you think about that there?
Well, he did this experiment where he got his camera very close to the water. It was only like a few inches above the water level, just by the pier. And he took video of something, I think it was about 15 miles away or so. And he could see traffic lights on the waterfront. The beach was actually obscured in these videos, which was interesting. He didn't really pay much attention to that, the fact that there was actually things being obscured by the horizon. But he did pay attention to the fact that you could see these traffic lights. And I said to him it was probably due to refraction. When people say that there are things that are visible that shouldn't be visible, there's usually one of two things going on. Either they've made a mistake in their calculations, or there is some kind of refraction going on. And atmospheric refraction is a very well understood thing. It's been fairly well understood for a very long time. And basically, light bends towards a more dense medium. So if light is going through the air and the lower air is more dense, which on average it normally is, then it will bend down, which means it kind of goes around the curve of the Earth a bit, which allows you to see a bit further over the horizon than you normally would. And this is especially true over water. There's a lot of variation when you go over water, because water is normally colder than the air around it, especially during the day. So when light is going over water that is a bit cold, it only takes like a degree or two as well. It doesn't really have to be like a lot colder, just like a small amount will do it over a long distance. Then the light will bend down a bit more than it does due to normal atmospheric pressure, and it can actually go many, many times further than you would expect. Because if it bends enough, it's actually bending the same amount as the curvature of the Earth. So you can actually get glimpses of lights, say like on lighthouses, or people using lasers on a distant shore, that are 10 times as far away as you would expect, because the light is going to bend around the curve. But people take these observations, and then they basically ignore refraction, and then they say, this proves that there's something wrong with the standard model of the Earth. And then when you talk about refraction, then they will basically nitpick it. But the problem with refraction especially in this situation where you're very close to the water, is that there's a lot of variation. I
Yes.
made a refraction simulator where you could alter the curve of the temperature gradient. So like how hot is it at sea level, and then how hot, like 1 foot above, 2 feet above, 3 feet above. It's very, very detailed curve that you can do. So you can say it's cold, it gets warmer, and then it starts to get cooler again. And I did a little ray tracing simulation that would show the results of this approximately. And the purpose wasn't to show exactly what the results was, it's to show how much variation there is. When you move the temperature like 1 degree to the side, one side or the other, then the distant shore kind of springs into view, or it kind of gets distorted and it gets elongated. So it's very, very possible to have refraction showing something in the distance. I think Dr. John's argument kind of boiled down to that he thought that the sea wasn't actually colder than the air. So if that was true, if the sea was a bit warmer than the air, then what would actually happen is the light would actually bend upwards, and you would see even less of the distant thing. And that's that can actually happen at night because the air cools down and gets to a state where it's actually cooler than the water, and so the warm water is actually warming a layer of air, which creates kind of a temperature inversion, and you
see,
you get this effect.
you see when that happens, though, you see an inferior mirage, which is
Yeah.
in that layer. And I noticed he was too close to the water to be able to tell much. That was a very bad observation, in my opinion. Too close to the water, really. It just messes
Yeah, and
everything
I
up.
think one thing he did was he measured the temperature of the air and he measured the temperature of the water. But of course, he's measuring the temperature of the water right next to the pier when the water's only a few inches deep. And the vast majority of the water through that line of sight is going to be much, much deeper water, much further away from the shore. And if you ever go swimming, you'll notice that the water next to the shore is normally warmer than the water further out. So quite probably, even if he got, I think, results where it was about the same temperature, which means that it was almost certainly colder out in the bay. So you're still going to get this this curving over the top of the horizon, and there's no real mystery to it here. It's quite straightforward stuff. Like we know you can do experiments in your garage demonstrating the curvature of things from hot and cold. Like I took a cold pack from my fridge and I shone a laser over it, and it bent down, and I took something warm out and you could see that it bent up. Or you took a flame and it will bend away from the flame, and you take an ice cube and it will bend around the ice cube. These are things that you can measure yourself in your garage. They're not really that complicated.
Yes, that's right. So I generally don't have my interviews go too long. So I think I'll go. What's your favourite chapter or chapters in your book? You want to talk about those?
Well, I think my favorite parts of the books are actually the interviews that I do with the people who used to be conspiracy theorists. So I think a lot of people get the idea that if someone is a conspiracy theorist and they are very deep down the rabbit hole, then they become unreachable. And I interviewed 6 different people in the book, and each one of them used to be a very, very deep rabbit hole type conspiracy theorist, and it seemed impossible to both them and to the people around them that they could get out of it. But they all did, and they all did it in kind of different ways. But essentially, they all did it by learning new information, and to some degrees with the help of their friends. So for me, that's like one of the best parts of the book, because I think it gives hope to people who have friends and loved ones who are conspiracy theorists. There is the possibility that people will get out. It can take a long time, but people do get out of the rabbit hole.
Well, that's a very good story. I mean, we all love to see people escape from the rabbit hole, so to speak. So, I mean, that must have given you a fair bit of joy seeing that.
Yeah, and especially when they told me that I helped them as well, because it's good to be get some feedback from people. There are people who argued very strongly with me directly and then years later, they come back and they say, thanks to Mick, I got out the rabbit hole and you should listen to what he's saying. And, that's just makes it kind of worthwhile that you get that feedback from people down the line.
Oh, yeah, that's fantastic, mate. That's very good. So, unless there's, I know, maybe I could see when Soundly did his interview with you, he could say, "Oh, go on for hours." I can see that. Could happen, but I've got to go now myself. And
All right.
is there something that you'd like to talk about to finish up?
I don't think so. Well, perhaps like we could talk very briefly about Dr. John's objection, one of his objections to my stuff. Like it gets technical. These things always get technical eventually, because he started talking about a thing called Snell's Law, which is how light bends when it goes into water. Like here's the air, here's the water, like goes like that, and it bends a little bit towards the normal. And these things get technical. And he asked me if my simulator used Snell's Law, and I told him no, it didn't. And he got really upset about that for some reason, saying that it must have done, and he demanded that I give him the source code of my simulator, which I'd already done, because it's just a web page. It's just a JavaScript web page. You can just click on view source and you can see it all. It's all there, all the information, all the data. And unfortunately, I don't think he really understands the distinction I was making between Snell's Law and what I do, which is essentially you take a wave front, and that the top half's in one medium, the bottom half's in the other one, so that moves a bit faster, and so that bends the wave. And because it's a continuous medium like air rather than air water, it's different to Snell's Law. You can't really use Snell's Law for that. But he didn't really follow this, and because he has a very high opinion of his own intelligence, which is partly justified but not entirely justified, I think, got a bit of a mental block in kind of understanding what I was talking about. And I think everybody needs to try to check their own assumptions. And even if you feel like you're on the side of science and everything, don't automatically think you're smarter than the other guy. You got to try to step down a bit from like getting annoyed at people saying you're wrong, and think, are you actually wrong? What is the actual truth of the matter here? So I would just urge people on both sides of the argument to have a bit more humility and a bit more respect for the other person's opinions.
That's very wise words. I think that's good. We should always think about, could we be wrong, and have we got everything right, and double check ourselves all the time.
Mm-hmm.
Very wise.
Yeah.
Okay.
And also, I would say, don't try to hold a discussion using very long YouTube slideshows, which is something Dr. John likes to do. But I don't think it's really very conducive to constructive discussions, because the other person has to watch half an hour of basically the same thing over and over again. And so that's why I haven't really engaged him very much, because I just can't stand this. Why don't we just talk or exchange emails? It seems pretty ridiculous to have to swap videos. So yeah, consider the what's the most efficient way of communicating if you actually want to communicate.
Wise words again. Thanks. That is very, yes. It does become a bit of a tit for tat videos game, doesn't it?
Yeah, which isn't helpful. Yeah.
Okay. Well, thanks, Mick. That's been fabulous to talk to you, and you have a lot to say, and I'm sure that if we had you on here again, that we'd go on easy for another hour. But
yeah, well, I'd be happy to.
Today we'll call it quits here, and thanks a lot. We'll see you around the traps.
All right.